Good morning, one and all. I am Kranti JS from ECE of Electronics and Communication Engineering. I am ready to discuss some topics on non-conventional energy resources. Geothermal power generation. In geothermal power generation, groundwater is heated by a magma reservoir to high temperature, high pressure steam that is used to power a turbine to generate electricity. Since delivering Japan's first practical thermal power plant in 1960, Fuji Electric has developed about 60 geothermal turbines both in Japan and abroad, including the world's largest 140 MW plant in addition of manufacturing the individual parts of equipment used in power plants. We are also engaged in the overall power design, manufacture and construction. Advantages of geothermal power generation. Environmentally friendly. Geothermal is more environmentally friendly than conventional fuel sources such as coal and other fossil fuels. In addition, the carbon footprint of a geothermal power plant is low. While there is some pollution associated with geothermal energy, this is relatively minimal with compared to fossil fuels. Renewable. Geothermal energy is a source of renewable that will last until the earth is destroyed by the sun in around 5 million years. The host reservoirs within the earth are naturally replenished, making it both renewable and sustainable. Advantages of geothermal power generation. Huge potential. Worldwide energy consumption is currently around 15 terahertz, which is far from the total potential energy available from geothermal sources. While we can't currently use most reservoirs, this is a hope that the number of exploitation geothermal resources will increase the ongoing research and development in the industry. It is currently estimated that geothermal power plants could provide between 0.0035 and 2 terawatts of power. Sustainable or stable. Geothermal provides a reliable source of energy compared to other renewable resources such as wind and solar power. This because is always available to be tapped in. Heating and cooling. Effective use of geothermal for electricity generation requires water temperature of over 150 degrees Celsius to drive turbines. Alternatively, the temperature difference between the surface and the ground source can be used. Due to the ground being more resistant to seasonal heat changes than the air, it can act as a heat sink source with the geothermal heat pump just 2 meters below the surface. Reliable. Energy generated from this source is easy to calculate since it does not fluctuate in the same way as the other energy sources such as solar and wind. This means we can power output from the geothermal plant with a high degree of accuracy. No fuel required. Since geothermal energy is naturally occurring resource, there is no fuel required, such as with the fossil fuels that are finite resources which needs a mining or otherwise extracting from the earth. Rapid evolution. There is a great deal of exploration into geothermal energy at the moment, meaning the new technologies are being created to improve the energy process. There are an increasing number of projects to improve and grow this area of industry. With this rapid evolution, many of the current costs of geothermal energy will be mitigated against. Disadvantages of geothermal power generation. Location restricted. The largest single disadvantage of geothermal energy is that location specific. Geothermal plants need to be built in places where the energy is accessible, which means that some areas are not able to exploit these resources. Of course, this is not a problem if you live in a place where geothermal energy is readily accessible, such as Iceland. Environmental slide effects. Although geothermal energy does not typically release greenhouse gases, many of these gases stored under the Earth's surfaces atmosphere during digging. While these the gases are also released, naturally the rate increases near geothermal plants. Earthquakes. Geothermal energy also runs in the risk of triggering earthquakes. This is due to alternations in the Earth's surface structures as a result of digging. This problem is more prevalent with embedded geothermal power plants which force water into Earth's crust to open up fissures to greater exploitation of the resources. However, since most geothermal plants are away from population centers, the implications of these earthquakes are relatively minor. High cost. Geothermal energy is an expensive resource to tap into, with price tags ranging from around 2 to 7 million from a plant with a 1 megawatt capacity. However, the upfront costs are high. The outlay can be recouped as the part of long-term investment. Sustainability. In order to maintain the sustainability of thermal energy, fluid needs to be pumped back into the underground reservoirs faster than it is depleted. This means that geothermal energy needs to be properly managed to maintain its sustainability. It is important for industry to assess the geothermal energy pros and cons in order to take account of advantages while mitigating against any potential problems. Applications of geothermal power generation, space heating and cooling, generation of electric power, industrial processes. Other applications includes desalination of water, heavy water production, extraction of minerals from geothermal fluids, timber seasoning, etc. However, the general usage is present until for power generation and space heating purpose. District heating system and direct use. Heating and cooling system. This application is about harnessing the heat from the Earth's interior directly as thermal energy to produce electrical energy in geothermal plants.